at all positions. Find U minimum. Okay, now a different situation I brought it directly. So let's analyze this one. So you have to analyze now. So go for this. Here the bob is there. So what are the forces? So F will be like this, mg. Here it will have velocity v1. What about tension? Will be maximum here. Then when bob is here, the forces F and mg. Tension, I think cannot be zero here. Just keep on draw the diagram. Here F, this mg. The resultant of all forces should act towards center. So now this should be tension. Here also not possible. Then we'll go for next this one. The force F, this mg. Now where the critical point can be. The resultant of F and mg will act towards the string. So what about here? Mg is acting. The resultant of F is not acting. So the tension can be minimum here. There's a one method is what in the books they're telling. Again, what you should do, you should solve the same method like earlier what we did. Somewhere I assume that one this angle is theta. Then this will be theta. Then what is the equation we should write? And the equation will be, this is T, let this be mg. So how we have to proceed? The similar way, mu square by 2 plus work done by the applied force. What is the work done by applied force? So minus FL cos theta, FL sin theta. Work done by gravity, L plus L cos theta equal to mv square, v5 square, I'll write it, or v5 equal to v. This is the thing. Then you will write the equation T5, or let it be same symbol, T5 plus mg cos theta plus f sin theta. Now what is the condition? When this will be minimum, v5 will be minimum when tension is 0. You can see from here remaining all are constant. So when v5 will be minimum when tension tends to 0. So therefore I'll bring a condition. This I don't know theta. Theta I'm making a guess. This I'll put in 2. Then I'll go for the differentiation. The same method like what we did earlier. Here in terms of f will come. Okay, let's see the mathematics. What is there in that one? G v5 will be this is 2, no? Just check once. I think mv5 square.
Sir, GL cos theta plus FL sin theta.
Okay, I did know same thing.
Yes, sir.
Yeah. Now the what will happen? We'll solve for u. U will be 3FL to 2 will multiply 3FL sine theta by m. Okay, this will be 3GL cos theta, 3G. Anybody just confirm if I am right? 3FL sine theta will come.
Sir, that should be f by m L sin theta.
I made no, m is there, no denominator.
Sir, no sir, in previous equation sir, m by 2 GL cos theta, in that f by m
For
is
F
there.
it is not there, sir. M.
Yes
Yes,
sir,
sir.
f
Here
by m.
m should be there. Huh?
Yes sir.
Here m should not be there. Yeah, m should not be there. Okay, this one m should be there. Huh? Yeah. Now we'll do one thing. We'll rearrange this. 3GL cos theta again differentiating this with respect to theta and equating to 0. I'll differentiate first. Then above 0 minus 3 GL sine theta plus cos theta, equating this to 0. Tan theta is equal to f by mg. So the value of f will determine what should be the value of theta. Okay, now from after this, what you should do, bring the sine theta and cos theta, substitute there, you'll get that u minimum. Please you solve this. I'll go for the next one more. So how to identify critical point? So we should write here now. What is the thing? What all the forces that are acting on the bob, their component must act along the string. This is not a like in almost every problem this is noticed here. You can see previously also the component of pseudo force and the weight. Here the applied force and the weight. Component of those, if they act along the string, the tension can be minimum. So this will be critical point. So we should apply now. If at critical point, if the bob is having critical velocity, it will complete the vertical circle. Now, if you project with a speed what happen at critical point, it should have critical velocity. Then it will complete the vertical circle. Critical point need not be always at highest point. That's what previous problem I brought it here. Very first vertical circle motion it was here. Now it is here. So critical point, can it be here? Yes, I can make it here also. We can make it here also. Now instead of applied force, if I apply force in this direction, let it be. Then identify where tension can be 0. If I apply force vertically up, then tension can be 0 here. Here tension will be non-zero. Then the critical point will come here. Okay, this is one basic idea of analyzing this one, vertical circular motions. It's a purely math based one. You should differentiate Now, how to identify? The best thing is like where the what all forces that are acting on the bob, their components, if they act along the string, there the tension can be minimum, and that is the critical point. That is the reason why I made a guess here. Why not here? You should look at the force. Its component is not acting along the tension, so it cannot be critical point. This is what happened after learning several examples. We are concluding. Otherwise, there's the best mathematically. There's the best way of concluding here. I'll go for the next one. And now, one more example. Like if it is a